Hello, we're going to start off the pre-calculus video by talking about one of the most important concepts in elementary mathematics. And that concept is about a function. What is it? What is a function? What is it? Well, there's many different ways of defining it. Basically, you have an input, and the function does something to that input, and you get an output. Suppose you have f of x is equal to x over 5 plus 2. My question is, can you say what f does to x in words? That is, can you read on the right what I have circled? Can you read what that says, or can you translate what that says in words? Okay, now what's in the brackets happens to be what you see, x. So when you see x, it'll be very nice if you call it what's in the brackets. What's in the brackets gets divided by 5, and then you add 2 to it. That's what the rule does. That's what f of x does. It takes what's in the brackets, it divides it by 5, and adds 2. And that's what this exercise is going to be for right now. State in words what f of x is doing. It takes what is in the brackets or parentheses, whatever you prefer to call it, takes what's in the brackets, divides it by the number 5, and then it adds 2. If you can say in words what f of x does, what f does to x, namely it divides it by 5 and adds 2. Let me say it slightly different. If you can say what f does to what's in the brackets, then you have it made. It divides it by 5 and adds 2. So if somebody asks you what f for 13 is, you say, oh, it's simple. I'm going to take what's in the brackets, I'm going to divide it by 5 and add 2. And the rest is arithmetic. This is the part I'm worrying about right now that you can do. If somebody asks you what f of a plus b is, you should not be afraid. You say, I'm going to take what's in the brackets, which is clearly a plus b. I'm going to divide it by 5, then I'm going to add 2. There'd be no point to write down what's in the brackets and only divide part of it by 5. Take what's in the brackets, a plus b, divide the whole thing by 5 and add 2, just like it says here. What does f do to what's in the brackets? If this is what you're given, you look at what's in the brackets, it's x. Call it what's in the brackets on the right side. It takes what's in the brackets, it divides it by 5, and it adds 2. And if you can do that, these problems won't be difficult at all. Because you know what to do in words. People don't like math, and I'm getting the math out of it. Math can you say it in words. But then you do have to do some arithmetic, like 13 over 5 plus 2. You'll have to compute that. If you're given that the name of another function is k of x, and this is equal to the square root of 3x minus 2. What does k do to what's in the brackets? Well, it multiplies it by 3, and then it takes away 2. And then it takes the square root of that. It multiplies what's in the bracket it multiplies by 3, then it subtracts 2, and then takes the square root. If you can say that in words, if you can look at this and say this, you got it made. Because if I ask you what k of, let's see a good number, 9, 11, 13, 15, 17, 19. If I say k of 9, well, you should say, I'm going to take what's in the brackets, I'm going to multiply it by 3, or at least the note that you're multiplying by 3, and then taking away 2, and then taking the square root. If you prefer, you can say that you're taking what's in the brackets, and 3 is being multiplied by what's in the brackets, and then you're taking away 2, the square root. That is, it doesn't matter if you write 3 times 9 or 9 times 3. Either way, you get 27, take away 2, which is 25, and you take the square root of that, which is 5. Take what's in the brackets, denote you're multiplying it by 3 and then taking away 2, and then take the square root of it. I don't care what's in the brackets. I'm going to multiply it by 3, and then take away 2, and then take the square root of it. Okay, the exercise is to write these functions in words. If you can say it in words, you got a good handle on it. If you were told that the function g of x is equal to 3x squared minus 9. Well, what does g do to what's in the brackets? That is, what does g do to x? Well, it squares it, and then it multiplies by 3. And then it takes away 9. It doesn't multiply by 3 first. It's 3 times x squared minus 9. It squares what's in the brackets, it multiplies it by 3, and then it takes away 9. That's the rule. It takes, so don't write this part down or assume that it's written down. It takes what's in the bracket, it squares it, multiplies by 3, and then it subtracts 9. It takes what's in the brackets, that's in the front, it squares it, it multiplies that result by 3, and then that result, it subtracts 9 from it. So, if I asked you what g of a minus b is, well, you take what's in the brackets, and maybe you can put brackets around it. It takes what's in the bracket, it squares it, it multiplies it by 3, and then it takes away 9. There it is. What if I give you this? What if I give you that h of x minus y is equal to 3 times, let's make it 8 times x minus y cubed plus 11. Well, what does h do to what's in the brackets? It doesn't just have to be x or y or t. It can be very complicated. It can be x minus y squared. What is x doing, what does h do to what's in the brackets? What is being done to x minus y squared? Well, x minus y squared is right there. It's being cubed, multiplied by 8, And then would you believe it having 11 added to it? Whatever in the brackets, it gets cubed, multiplied by 8, and then it adds 11. Well, we don't say past tense. It cubes what's in the brackets, it multiplies it by 8, and then it adds 11. I don't care what's in the brackets, I care what's happening to what's in the brackets. So if somebody were to ask you what h of z would be, you should say, well, I take what's in the brackets, z, I cube it, I multiply it by 8, and then I add 11. Of course, I'm not cubing anything, I'm not multiplying by 8, I'm not adding 11, I'm denoting that's what you should do. Okay, somebody asks you what h of 2 is. You should cube it, 2 cubed is 8, you should multiply that by 8, that's 64. I cubed the 8, I cubed 2, I got 8. I multiply by 8, that gives me 64. And then I add 11, if I do my math right, that's 75. I cube 2, I multiply it by 8, and I add 11. This is 8 times 8 plus 11. It's 64 plus 11, or 75. You should be able to say in words what the function does to what's in the brackets. Doesn't matter if what's in the brackets is hard looking or easy looking. Doesn't matter. And to really stress that, if on the top here, instead of having g of x, if I had g of something complicated, x cubed minus y over ln of z to the 4th power, if I had that, well, the rule might be this. Ln of z to the 4 squared minus 9. I mean, basically say, you know what? What's in the bracket is really, really complicated looking. You know what? I'm going to call that W. Whatever in the brackets, I'm just going to come and call it W. So G of W equals, and wherever I see that same mess, whether I see it 1 time or 2 times or 23 times or no times, wherever I see it, I put W. So basically G of W is equal to 3W squared minus 9, which is very similar to what we have on the left here. Okay, instead of W, we have X. Okay. I mean, I could say, oops, you know, I don't like W, I like X instead. So wherever I see W, I put X. The reason I didn't put X at the beginning is because I already had X's in the brackets. I had X cubed minus Y. See what's being done to what's inside the parentheses. And then you can take F or G of anything. So now we're going to work backwards. Give you the words and ask you to list the function. And you can call a function whatever you want. That is, you can call it F or G or H or K, any letter you choose. How about what we do to what's in the brackets is we multiply by 7, then add 4. Well, how about we call what's in the brackets X? What do we do to what's in the brackets? We multiply it by 7. Okay, I just did that. Then I add 4. Done. Give it a name. We'll call it h of, since the variable is x, we call it h of x and not h of t. How about what's in the brackets? We divide by 4, then we subtract 14. So what's in the brackets, we divide by 4. Let's call what's in the brackets t. What's in the brackets, we divide by 4, then we subtract 14. And if I call this the J function, what goes in the brackets is whatever letter you see. I see t. J is a function of t. To know what the right-hand side is, I have to tell you what t is. For example, if I tell you s is 13, you don't know how much this is. But if I tell you t is 4, you'll say, oh, t is 4. 4 over 4 is 1. 1 minus 14 is negative 13. So when I ask you what j of 4 is, I'm telling you what t is. I'm telling you t is 4, not s is 4. The right-hand side is in terms of t. So it's j of t. If the right-hand side would have been in terms of L, I would say j of L. Okay, let's try another one of these. And you won't be given these 3 dots, but I'm telling you, in front of the word says what's being done to what's in the brackets is it's being squared. It's being squared. Then add 13. Then take the square root. Square root. Okay, so to whatever in the brackets we square. So let me remove the d, past tense, we square. So let's call what's in the brackets y. To whatever in the brackets, we square it. Then we add 13. Then we take the square root. There it is. I took what was in the brackets, I called it y. I squared it. Then I added 13. And then I took the square root. And this will be, we'll call it the Decay Function. And it's going to be k of what? Well, what only letters I see here is y. K is a function of y. To get k, I have to tell you what y is. If I tell you that y is, try to get a nice number that's going to work. Let me think, please. Well, I mean, if y is 5, what's k of 5? Well, you square 5, you get 25. You square what's in the brackets, then you add 13, and then you take the square root. When I square what's in the brackets, namely 5, get 25. If I add 13 to 25, I get 38. Then I take the square root of it. Okay. In my opinion, this is very important stuff. If you can say this stuff in words, then you really shouldn't have trouble with functions. A lot of students have trouble finding f of this or g of that. And that's because they can't say the function in words. I mean, one more complicated one. If I tell you that L of j is equal to j plus 4 over j plus 7. Well, in words, you add 4 to j, and then you add 7 to j, and you divide the two. Whatever j is in the numerator, add 4. In the denominator, add 7. If it says 3j squared plus 4 over 7j plus 7, whatever in the brackets, for the numerator, you square what's in the numerator, you square what's in the brackets, I meant to say, you multiply that by 3, then you add 4. And now you have the numerator. And the same thing's going to be in the brackets. For the denominator, you multiply it by 7, and then you add 7. And now you have the denominator. And you do the division, and you get the answer. For example, if somebody asks me what j of 3 is, I'll take, for the numerator, I'll take what's in the brackets, and I'll square it. And then I'll denote I'm multiplying it by 3. And then I'll denote I'm adding 4. The numerator is going to be 3 times 9, 27, plus 4, 31. In the denominator, I'm going to take what's in the brackets, I'm going to denote I'm multiplying it by 7, and then adding 7 to that. 21 plus 7 is 28. I don't see that being reduced, so L is 3 in reduced form, 33 over 28. Know how to say this stuff in words. Make your life a bit easier. Okay. So, let's just look at things like this. Suppose I tell you that f of x is equal to 3x minus 1. And I ask you to find f of 3 or f of 31. I ask you to find f of negative 2. And I ask you to find f of the square root of 5. Now, we'll do this 2 different ways. If you understand how to say what's being done to what's in the brackets in words, and after all, there's what's in the brackets, it's being multiplied by 3, and then 1 is being taken away. So I take what's in the brackets, I denote I'm multiplying it by 3, and I'm taking away 1. This is 62. I'll try that again. 3 times 1 is 3. Boy, was I wrong. And 3 times 3 is 9. It's 93. I guess I multiplied it by 2 for some reason. 3 times 31 is 93. Take away 1, 92. After of negative 2, I take what's in the brackets. I denote I'm multiplying it by 3, and then taking 1 away. This is negative 6 minus 1, negative 7. I take what's in the brackets, I multiply it by 3, or I denote I'm multiplying it by 3, then I take away 1. And that cannot be simplified anymore. This is not 2 square root of 5. I mean, for example, if you have 3 times a really large number, 100 million, say you have 3 times $100 million. That is, you have $300 million. An awful lot of $1 million. You have 300 of them. And then you go out and buy an ice cream cone for $1. Well, 3 minus 1 is 2. You don't have 2 times 100 million. That is, you don't have 200 million. You started out with $300 million. You spent $1, and now you only have 200 million? Not true. Not true at all. Okay. Now, I want to go over these problems again, and this time I'm just going to say a different way of how to do them. You know how some people write x this way. Maybe not as big as that, but some people write x that way instead of this way. And I mean in everyday life. This is how they write x. Well, you know what? Sometimes I write x that way. Sometimes I write x that way. That is f of x. And now I'm going to write x this way. F of x is 3x minus 1. Whatever they put in, so coincidentally this looks like brackets. But I call it x, 3x minus 1. If somebody asked you to write 3x minus 1, you would probably write 3x minus 1. I'm just asking you to write x that way. So if I ask you to write 3x minus 1, you write that. Okay, that's how you write x. And the nice thing about this is then whatever they put in the brackets, so do you. In other words, I'll put the 31 back in a moment. F of x is equal to 3x minus 1. If they put 31 in the brackets, not a problem, so will I. I still get 93 minus 1, or 92. F of x is 3x minus 1. If they put minus 2 in, so will I. We get negative 6 minus 1, same answer, negative 7. F of x is 3x minus 1. If they put square root of 5 in, let them do that. 3 times square root of 5 is 3 square root of 5 minus 1. Okay. Now, some students may get confused if f of x was just a little bit more complicated. But before we do that, I like to do one more part on this last one. Remember that f of x was 3x minus 1. If you were asked what f of a plus b is, well, call it f of x for now. F of x is 3x minus 1. If they put a plus b in the brackets, put a plus b in the brackets. You want to distribute, fine. 3a plus 3b, 3a plus 3b minus 1. Done. If they ask you what f of x plus h is, well, f of x is 3x minus 1. They put x plus h in, you put x plus h in. Simon says, just write x, instead of x, write brackets. Now, like I was about to say, some students get confused with the following. Like when they have x squared. Okay? Now, let's be honest. We're talking art now, not math at all. This is the area that took up x. Square is not inside there. That is, we do not have x squared. The square is outside the x. It is not inside the x. Wherever, in any book you look at where you have x squared, you can definitely find the area where the x is and the square is outside, or cubed, or to any power. Okay, so why on earth am I saying this? Well, let's see. If you have that g of x, if you have the g of x is x squared minus 4x plus 9, and you're asked to find g of negative 3. Well, first you should say g of x is equal to 3x squared minus 4x plus 9. And I don't know why I said 3x squared, excuse me. It just says x squared, so I shouldn't write 3x squared. Sorry about that. x squared. X squared. And you should be able to read it backwards. Instead of brackets, say x. Brackets, square, minus 4, brackets, plus 9. If this is exactly our rule here, I'm okay. If they put negative 3 in the brackets like they did, so should you. So should you. Let's work this out, and then I'll show you. Sometimes I don't like to show you mistakes people make, but this time I will. Okay, let's erase all of this. Okay. Well, this number is 9. This number is negative 12 plus, and this number is 9. Well, we have a rule in math that says we can change both of those signs. 9 plus 12 is 21, plus the 9 at the very end gives us 30. A lot of students will say, oh, this is easy. Negative 3 squared minus 4. Maybe here they'll write negative 3 plus 9. But this is not correct. This is not correct. Negative 3 squared and negative 3 squared. Obviously they sound alike, but they're different. 3 squared is 9. I'm not arguing that. That's 9. But here's 3 squared with a minus in front of it. Oh, 3 squared is 9. Negative 9. Negative 9. But over here, what's being squared is what's in the brackets. This is negative 3 that's being squared. Negative 3 times negative 3, positive 9. They're not equal. That is, negative 3 squared, negative 3 squared does not equal negative 3 squared. They're not equal. They're not equal. But now, if you do what I'm saying with the brackets, you won't have the trouble. G of x is x squared minus 4x plus 9. If they plug in negative 5 in the brackets, or let's keep it negative 3, then you should put negative 3 in the brackets. That way, you'll never ever write down the negative 3 squared that way. You wouldn't write it down this way right here. Because if they put negative 3 in the brackets, so should you. Every time you see brackets, negative 3 going to the brackets. Every time. Okay, it would be just very bad artwork on your part to put just 3 in the brackets with a negative in front. If you are told that g of x is equal to x squared minus 4x plus 9, that is, g of x is x squared minus 4x plus 9. If they put negative 3 in the brackets, you shouldn't just put a 3 in the bracket with a minus in front. Okay, that would just be suicidal. If they put negative 3 in the brackets, so should you. Now, let us look at a slight variation of this problem. In fact, I don't care about the minus 4x plus 9. Never really did care about that. Suppose we define another function, h of x, and h of x is not x squared, it's minus x squared. Remember, there's x, there is x. So, h of x is equal to negative x squared. I hope this is clear as day that that minus sign is not inside the x. It is not right there. It's not right there. It's not inside the x. It's not in the area where the x is. It's in front of it. And like I said, some people write x this way. Some people write x that way. As algebra students, we write x this way. hx is negative x squared. Okay, so if they ask me what h of 3 is, I'm not going to say 9. I'm not going to square negative 3. 3 squared, this here is 9. 3 squared is 9. Somebody went and put a minus sign in front of it. So try not to get caught up on that. Sometimes the minus goes inside the parentheses. Sometimes it goes in front of. Suppose I were to tell you that k of x is equal to 3x squared minus 4x cubed plus 5x minus 11. And I asked you to find k of negative x. Okay, I don't care what they put in the brackets. I come right down here. Instead of x, I put brackets. I'm reading the top line. K of x equals 3x squared minus 4x cubed plus 5x minus 11. Every detail is the same, except x is written that way. You have the square, you have the minus, you have the 4, you have the new way of writing x, you have a 3 in the upper right hand corner, you have a 5, you have a plus, you have the new way of writing x, you have the minus sign, and you have the number 11. Everything must match up. If they put negative x in the brackets, Simon says, you put negative x in the brackets. Putting negative x in the brackets is not putting x in the bracket with a minus in front. That doesn't even sound the same. Putting negative x in the brackets is going inside the bracket area and putting negative x. Putting x in the brackets and doing other stuff outside, well, you didn't put negative x in the brackets and you weren't told to do anything in front of the brackets. Okay, now let's just evaluate. Let's evaluate. It's this value minus this value plus that value minus that value. What is 3 times negative x squared? It's 3 times negative x squared. 3 is 3, and negative x squared is x squared, and 3 times x squared, 3x squared, minus 4 times negative x cubed. There's 4 times negative x cubed. Well, 4 is 4, and negative x cubed. Negative times a negative times a negative is a negative, and x cubed is x cubed. That is negative x cubed means negative x times negative x. What's in the bracket gets multiplied by itself 3 times because of this 3 here. Well, a negative times a negative times a negative is a negative. I meant to write an x there. And x times x is x cubed. So it's 4 times negative x cubed, which is negative 4x cubed. Fine, you can change those. 5 plus 5 times negative x is negative 5x minus 11. You always want what you're adding or subtracting to be positive. Whatever you're adding or subtracting should be positive. Except maybe for the first term. Well, here we're adding something positive, which is good. Here we're adding something negative, which is not good. We'll come back to it. here we're subtracting positive 11. I mean, I can easily change this to where we're adding or subtracting a positive quantity. I can change both signs. Instead of adding, we're subtracting, and instead our negative 5x is positive 5x. So basically, you have 3x squared plus positive 4x cubed, which is just 4x cubed, minus positive 5x, which is just 5x, minus 11. Okay, but again, what happened below this line, that's elementary algebra. What happened above it, that's the pre-calc material. Being disciplined to putting that notation, that is parentheses, wherever you see x's. And if they plug negative x, and this is k of x, whatever they plug in here, you put here, and here, and here. And they should look exactly the same as what was in the first set of parentheses. And then their mathematics starts. First part I consider as artwork. Write x differently, and then play Simon Says. Whatever they put inside the parentheses, you put inside your parentheses. So for example, if they tell you f of x is equal to 3x plus 4, and they want you to find f of a plus h minus f of a divided by h. Well, this is three things. It's this expression minus this expression, and then the whole thing gets divided by h. You need to find out what each of those pieces are. Here's the division line, and there's that minus sign in the middle. We first, to the left of this minus sign, we need to find out what f of a plus h is. Well, let's slow it down. F of x, I'm reading the top line, f of x is equal to 3x plus 4. And if they want to put a plus h in the brackets, whatever. I'm going to put a plus h in the brackets, and we're done. It's 3 times a plus h plus 4. Another way of saying it is, what does f do to what's in the brackets? Reading from the top line, it takes what's in the brackets and multiplies by 3 and adds 4. If they're going to put a plus h in the brackets, not a big deal. I'm going to take what's in the brackets, I'm going to multiply it by 3, and then I'm going to add 4. And notice I got the same answer. Now I'm going to take away f of a. Well, if f of x is 3x plus 4, then f of a is just that, 3a plus 4. So it's f of a plus h minus f of a. 3a plus 4. Alternatively, you can say what f does to what's in the bracket is it multiplies it by 3 and adds 4. We have that from right here. What's being done to x is being multiplied by 3, and then you add 4. Well, that's just what I did. And we don't forget, please, to divide by h. The pre-calc is over. That's over. The rest is simplification. The rest is simplification. Let's simplify, if possible, what's inside each of those big brackets. We have 3a plus 3h, 3a plus 3h plus 4. In the second bracket, we really can't simplify. 3a plus 4. And all of this is being divided by h. Now what you have to realize is that when you subtract two quantities that are exact, when you subtract two numbers, the answer you get is how much different or how much bigger one number is than the other. 7 is 4 more than 3. That's why the difference was 3. Subtraction is difference. 8 minus 2 is 6. Why? Because this number is 2 more than that number. When is the answer 0? When these two values have no difference, like 7 and 7. They have no difference. -7 and -7, they have no difference. They're the same number. One is not bigger than the other. So when you subtract, you get 0. Most students, if you write down x minus x is, what is x minus x is, they'll all jump on 0. They'll say, ooh, I know that it's 0. Well, x is the placeholder for any number. Any number minus that same number is 0. That is -13 minus -13. I'm just being nice and telling you what x is now. This is 0. You subtract the same two quantities, you get 0. They just have to look the same. Exactly the same. One can't be positive and the other negative. They both have to be negative or both being positive. And you have to be subtracting them. Well, this is clear as day, looks like 3a. And this looks like 3a and we're subtracting them. 0. This looks like +4 and this looks like +4. And we are subtracting them by 4 minus 4 is 0. The only thing that survived is +3h over h. Now, talk about this. X over x is not 1. Nonsense. It's not. I don't care what your teachers may have told you in the past. X over x, not 1. I mean, fine. 5 over 5 is 1. 0.7 over 0.7 is 1. 2/3 divided by 2/3 is 1. Generally, if the top and the bottom are the same, you get 1. And they can even be negative. They have to be the same numbers, like I said. You get 1. Problem is 0 over 0 is not 1. That is, when you divide the same two numbers, you don't always get 1. You don't. Okay. Let's get right into it. First video on pre-calc. Why is it not 1? Well, if somebody gives you or asks you what 8 over 4 is 2. Notice 4 times 2 is 8. That's not a coincidence. If somebody asks you what 10 over 2 is, you may say 5. And one way of checking is to say, oh, 2 times 5 here, that's 10. In fact, if you don't know what 16 divided by 8 is, not a big deal. You can ask yourself, 8 times what gives you 16? The answer is 2. Well, and yeah, if you had 13 over 13 and you really didn't know what that equaled, you can ask yourself, 13 times what gives you back 13? The answer is 1. So now, what about 0 over 0? What does that give you? What does that give you? Let me erase this, please. Okay. How much is 0 over 0? Well, you might say it's 0. Let's see if you're right. 0 times 0, yep, that's 0. So it equals 0. But wait a minute. What about 17? I like 17. Oh, yeah. 0 times 17 is 0. That is, it equals 0. What about -3/4? Oh, 0 times that number. 0 times any number is 0. 0 times -3/4 is 0. How about 4? 0 times 4 is 4. Now, let's go over this carefully. If 0 over 0 equals 4, and it also equals 17, then shouldn't 4 also equal 17? How can two different numbers both equal 0 over 0? If 0 over 0 really does equal 4, and it really does equal 17, then 4 equals 17. The problem with that is that we can't allow that to happen. I mean, you have every right on an exam where each question is worth 10 points. Every time you do poorly on that questioning, your teacher only gives you 4 points, you can say, you know what, teacher? 4 equals 17. Don't give me 4. Give me 17 points. Every time you gave me 4 points, it should be 17. So, if on 10 problems that are each worth 10 points, that's 100 points total, you got 4 in each one. 4 plus 4 10 times is 40. You have every right to say, I want 17 10 times. I want 170 on this test. I got the highest grade in the class. I did better than you. You, the teacher, only got 100. I got 170. Well, we can't allow this nonsense. We can't allow 4 equals 17. You loan me $4 today, and I say, well, you owe me $4, but 4 is 17. Give me $17. Come on. This is absurd. That is, we can't allow 0 over 0 to be any number we want. In fact, it's called indeterminate, because we can't really determine what it equals. You can't compute 0 over 0. Okay, so let me just erase this, please. And then we'll talk about what x over x, or h over h, or k over k equals. X over x is called the piecewise function. It equals 1 if x is not 0. If the top and the bottom are both the same, but they're not 0, when you divide them, you get 1. But if x is 0, I just told you what 0 over 0 is. It's called indeterminate. Indeterminate. Why am I doing all that? Because right here, you are not allowed to cross off h over h. This is a piecewise function. You get 3. If h is not 0, h over h is 1, and you get 3 times 1 is 3. And this is if if h is not 0. If h is not 0. You get indeterminate if h is 0. 3 times 0 is 0. 3 times 0 is 0, and h is 0. 0 over 0 is not 1. It's indeterminate. So if anyone tells you x over x, or h over h, or k over k is 1, you say no. It's not. All you have to do is give them an example. Say, well, what if h is 0? 0 over 0 is not equal to 1. Okay, so making a big deal of this, but the answer is right here. It's 3 if h is not 0. It's indeterminate if h is 0. Let's try some more like this. Suppose you were given that g of x is equal to x squared minus 9. And you're asked to find g of a plus h minus g of a over h. Let's do it by knowing what the rule is. What's being done to what's in the brackets is being squared, and then you take away 9. So we need to know what this piece is minus what this piece is, and then divide by h. Denoting that we're dividing by h is very simple. What's the first piece? Again, whatever is in the brackets, we square it, take away 9. Not a big deal. A plus h is in the brackets. I'm going to square it, take away 9. Minus. What's g of something? Take that something, square it, take away 9. Equals. The bottom is still h. Let's simplify the first bracket. A plus h squared. You square the a. So remember, x plus y. If you have a sum and you square it, I like to call this the first and that the second. You get the first squared plus 2 times the product of the first and second, which is xy, plus the second squared. Know that stop foiling things out. I mean, even if you foil out, you're not going to ask anything different. The first thing I asked was, what do you get when you square the first thing? That is, what's x times x? That's the first thing you're asking. What's x times x if you foil? The next thing I asked you is, what's x times y? You know what? That's exactly what you're asking. Why do I ask what 2 times it is, though? Because you're going to get it again. You're going to get it again. And then the last thing I asked you is, what's the second term squared? It's exactly what you're asking now. What's y times y? I say square, you say times itself. Same difference. I mean, I can say it over here. What's x times x? X squared. What's 2 times the first times the second? 2xy. What's the second is y. What's y times y? Y squared. Okay. Learn that rule. That way you don't foil out every time. It just takes forever. It takes an extra 10, 15 minutes for you to do your homework. Why bother? You have better things to do. I know I did when I was a student. Okay, so a plus h squared. A is the first, h is the second. You get the first squared, a squared, plus 2 times the first times the second, 2ah. Write the h a little bit bigger. Plus, then you got the second squared, h squared. That's just a plus h squared. Don't forget to take away 9. That's the first bracket simplified. Minus, the second bracket can't really be simplified. Remember, we're subtracting. The first bracket has a squared. The second bracket has a squared. When you subtract them, you get 0. The first bracket has negative 9. The second bracket has negative 9. When you subtract, you get 0. Negative 9 minus negative 9 is 0. It can't be 18. These numbers don't differ by 18. It can't be negative 18. It can't be 9. It's 0. It's 0. They differ by nothing. Okay, go back and rethink what subtraction means. You subtract the same quantities, you get 0. So, what did survive? Well, those two pieces survive. 2ah plus h squared over h. And whenever you have this formula, if you make no mistakes, h is going to factor out on the top. You can factor out in h. H times 2a is the same as 2a times h plus h times h gives you h squared, and this is all over h. Now, sometimes you get 2a plus h. When h is not 0, because this cancels out to 1. Other times you get indeterminate, because if h is 0, I'm at the very top. If you have h times 2a plus h. If h is 0, well, 0 times what's in the bracket is 0. And if you have h on the bottom, but that's 0, you get 0 over 0. That's garbage. That's indeterminate. You get indeterminate if h is 0. Sometimes the book says that you're studying from your teacher. Somewhere says h is not 0. If h is not 0, then these h's do cancel out, and your answer is 2a plus h. Okay, let's do a little bit harder one. Let's do a fraction. And in this case, I'll say h is not 0. That way we don't have to worry about it. That is h over h is 1. Any number divided by itself, as long as the number is not 0, is 1. Okay, so suppose I tell you that k of x is 1 over x. K is just a name. Don't get caught up on that. And I'm asking you to find k of a plus h minus k of a over h. And I'm telling you, h is not 0. It's some other number. It's just not 0. Well, again, you need to find this piece minus, and then you need to find this piece. And then you divide by h. Now, what does k do to what's in the brackets? I mean, one way to say it is to say it takes what's in the brackets, it puts it on the bottom, and it puts a 1 on top. But let's just look at that more closely. What if I give you a fraction like a over b? So what's k of a over b? Same rule always. Put what's in the bracket in the denominator, put 1 on top. But the rule for dividing is to keep the top the same, change division to multiplication, and flip over the bottom. B over a. Well, 1 times anything is the anything. So let's look at this more closely. K of a over b, k of a over b equals b over a. Oh, it takes the reciprocal. Reciprocal means put the numerator in the denominator, put the denominator in the numerator. Switch these. That's just what happened. It takes the reciprocal. After all, x is x over 1. So k of x is k of x over 1. But what we got was the reciprocal. That's what k does. It takes the reciprocal. K takes the reciprocal. Alright, let's look at this more closely. And let's see what the top right is going to equal. K of x is equal to 1 over x. Find this mess. Find that if h is not 0. Well, we know it's a fraction. What is subtraction? It's k of a plus h minus k of a over h. Well, k of anything is a reciprocal. K of a plus h. Just realize if there's no denominator, it's 1. K flips it over. That is, we get 1 over a plus h. K of a. Remember, a is the same as a over 1. K flips it around. We get 1 over a. Okay, that was the pre-calc part. The rest, 100% algebra. In the numerator, we don't really want to have a denominator. And in the denominator, we don't want to have a denominator. But in the denominator, we are okay. Because in the denominator is just 1. But in the numerator, we have a plus h as a denominator, and we have a as a denominator. We don't want that. So we need to find the least common multiple. We have to find one thing that goes into a plus h, that a plus h goes into, and also a goes into. We need to find one thing. What I'm putting circles by, they have to be the same. And we want a plus h to go into it and a to go into it. Well, for a plus h to go into this numerator, we better have a plus h. Because here, it goes in. So, if the two circles have to be the same, well then I'm forced to have a plus h here. But a doesn't go into a plus h. You can't say 2 goes in to 2 plus 3 because 2 goes in there 2 one time. That's not true because 2 plus 3 is 5. 5 over 2 is 2 plus 3 over 2. But here we're getting 4. 1 plus 3 is 4 over 2. I meant to say we're getting 2. 5 halves doesn't equal 2. What you really, if you were going to do the division, you have to divide the 2 into the 3, which is 1 1/2. 1 plus 1 1/2 is 2 1/2, which is 5 halves. Okay, so a doesn't go into a plus h. You need an a here. A goes right into it. So you have to put a in the first circle as well. That is the LCM is a times a plus h. A times a plus h. The product of the two. Don't think you just blindly always multiply the two. You might get it a lot bigger than you need. And then the problem's going to become a disaster. Instead of getting a linear equation, or you'll get a 5th degree equation. Okay, so let me just save a little space here. So I'm going to multiply this fraction by 1, else I change the value. When you want to change the way something looks, you multiply by 1. And how do you know you want to change the way things look? I don't want any denominators in the numerator. I don't want any denominators in the denominator. I am going to denote that I am multiplying each term by a times a plus h. Minus the second term, 1 over a. I'm going to denote that I'm multiplying it by a times a plus h. I multiply the numerator by a times a plus h. And now I'm going to take the denominator and I am going to denote that I'm multiplying it by a times a plus h. And again, you have to remember why we're doing this. We're picking a times a plus h for one reason. All our denominators go into it. That is, we won't have any more denominators. For example, 7 goes into 14 2 times. Our answer has no denominator. Our original problem did. It had 7 in the denominator. Alright, so let's see how we can get rid of the denominators in the numerator. And there never was, and there still are no denominators in the denominator. That is, our denominator is just this. If you just look below that line, there's no denominators. If you're just looking below that line, for there to be a denominator, it would have to say something like on the bottom, a cubed plus 7. Then there'd be a denominator, a cubed plus 7. But that's not the case here. There is no denominator. Alright, now let's see what's happening on the top right in this area here. A plus h goes into a plus h. Like I promised, no denominators. So all that survived is 1 times a, or a, minus. It says minus right there, minus. Let's write it bigger, I'm sorry. The circle kind of destroyed it. Minus. Minus what? Well, a goes into a, so all that survived is 1 times a plus h. And 1 times a plus h is just a plus h. Now, if you subtract, I agree that a minus a is 0, but you don't have this h left. You have minus h left over h times, well, I didn't mean to put the brackets around the a, but I can, times a plus h. Now, since you're told h is not 0, and even if h was 0, they're both the same number. But since h is not 0, I know that when I divide, I get 1. Of course, the numerator has the minus 1. So the final answer is negative 1 over a times a plus h. That would be your final answer. This is going to come up for the first few weeks in Calc 1. You need to be able to find k of a plus h minus k of a over h. Sometimes, if not more times than not, instead of the a in that formula, they'll just keep x. For example, if f of x was 2x squared minus 5, and they ask you to find not f of a plus h, but x plus h minus f of h, minus f of x over h. And we'll say h is not 0. This formula comes up enough where it has a name. It's called the difference quotient. The difference quotient. Quotient means divide, and it's difference. The difference quotient. Okay, so we need to find out what f of x plus h is, and then what f of x is, which, by the way, is given. It's given, and then we divide it by h. So when it has x's instead of a's, the second piece is a freebie, because they gave us what f of x is. So the whole job is to find out what this is. Well, what does f do to what's in the brackets? It squares it, it then multiplies it by 2, and then it takes away 5. I take what's in the brackets, I denote I'm squaring it, then multiply it by 2, and then I take away 5. That's f of x plus h. Minus f of x, which was given. 2x squared minus 5. And all of this gets divided by h. Okay? We're getting there. First bracket minus the second bracket. 2x squared minus 5. All over h. I guess I'm not going to have room. I'm going to write it above. X plus h squared. Well, we square the x plus we multiply x times h and then double it. And then we square the h. And all of that gets multiplied by 2. And then we take away 5. So what we really have in that bracket, distributing the 2, we have 2 times x squared plus 2 times 2xh. 2 times 2 is 4 times xh plus 2 times h squared. And let's not forget to take away the 5. Minus the second bracket is 2x squared minus 5. And all of this is over h. If it's a polynomial, if f of x is a polynomial, what's in the second bracket? Every piece in the second bracket will be in the first bracket. Like the second bracket has 2x squared, so does the first. And when you subtract them, you get 0. The second bracket has minus 5. What do you know? So does the first. So negative 5 minus negative 5 is 0. What's left over, you can factor out in h. What's left over is this and this. And what do you know? They have h in common. 4x times h is 4xh. Plus, because it does say plus right there, 2h times h is 2h squared. It's exactly right. Since h is not 0, this cancels out, and what's left over is your answer, namely 4x plus 2h. All right. Just try one more with these evaluations. It won't be with the difference quotient though. If you're told that g of x is equal to x squared minus 4, and you're asked to find g of these things, g of 2x, g of 3a squared, g of x cubed, those. Well, first thing you should do is say, well, what's being done to x? Is being squared. What's in the brackets is being squared, and then you take away 4. Oh, okay. I take what's in the brackets, the whole thing. I square it, I take away 4. 2x squared is 2 squared times x squared minus 4. 3a squared. I take what's in the brackets, I square it, take away 4. 3 squared is 9. A squared squared is 8 to the 4. 3a squared squared means to multiply it 2 times. The order you multiply is up to you. I choose to multiply the 3's first and the a's second. For example, this is very important. If you have 25 times 3 times 2 times 4, I claim that's a very, very simple problem. It's definitely not worth the time to go and run and get your calculator. What you need to do, it's going to take me longer to write it and say it than to do. I know 25 times 4 is 100. And what's left over is 3 times 2. Well, that's 100 and that's 6. 100 times 6, I'm done. 600. The order you multiply is up to you. You can multiply these two like I did, and then multiply those two, and multiply that result together. Well, I'm definitely going to multiply 3 times 3 together. Then I'm going to multiply a squared by a squared, which is 8 to the 4th. The order you multiply is up to you. So I wrote down what that equals, 9a to the 4th. Please don't forget to take away 4. Okay, next one. What's g of x cubed? Well, what does g do? It squares, takes away 4. It squares what's in the parentheses, and then it says take away 4. Okay. So I might be a little bit nervous, but I'm going to take what's in the parentheses, I'm going to square it and take away 4. And you need to remember that you multiply them. I mean, the easiest, look, either you multiply them or you add them. Probably the easiest one to look at is x. And it's x to the 1 to the 1. And if that's too confusing, you know, I mean, we know it's 1, and 1 plus 1 isn't 1, but 1 times 1 is. If that's too complicated, probably the next one to look at is really the one in front of us. This is whatever in the brackets, multiply it by itself 2 times. And x cubed means x times x times x. And x cubed means x times x times x. And we are multiplying x by itself 6 times. 3 plus 2 is not 6, but 3 times 2 is. You multiply the exponents. You multiply the exponents. Whatever you do, don't use this to remember the rule. For example, if somebody asks you what x to the 10 to the 5 is, now you know it's either x to the 50 or x to the 15. Now, if you look at x squared squared, if you add the exponents, you get x to the 4th. If you multiply the exponents, you get x to the 4th. So if somehow you figure out that that's x to the 4th, you still don't know if you're multiplying or adding them. I mean, how might you know that it's x to the 4th? Well, I'm squaring something. I happen to be squaring x squared. But whatever I'm squaring, I multiply it by itself 2 times. That means x times, this means x times x. That's x to the 4th. Okay, so I know it's x to the 4th. But I still don't know if I should add the powers or multiply. So, just keep that in mind. But you can always figure it out by looking at an exact example. Other than x squared squared, or 3 squared squared, or 4 squared squared. Because 2 times 2 is the same as 2 plus 2, and you're trying to figure out if you should add or multiply. But nonetheless, we're done. All right. We're going to stop it here, and we're going to make up the next video for finding domain and ranges.